Okay. Can everyone hear me? Yeah. That's cool. Welcome. This is Going Micro with the Symfony Microkernel talk. Actually, the title should be Going Micro with Symfony. It includes the microkernel, but there's a bit more. We'll be talking about how to strip down Symfony to be a bit smaller, and also how to understand what's inside Symfony so you can actually work better, more efficiently, and make better decisions when working with the framework. My name is Jakub Zalas. You can call me Kuba, which is short for Jakub. I'm a software consultant. I do all the code quality, TDD, BDD, all the DDDs things. I'm really into test-driven development as first approach. I'm also one of the Symfony core team members. So I mostly work with Symfony. So let's start with defining a micro framework. What is a micro framework? Could anyone give me a definition? It's a little framework.
I would say tiny framework.
Tiny framework.
Micro framework.
Yeah. The clue is in the name. So first thing I did, I went to Wikipedia and I asked Wikipedia, hey, what's a micro framework? And this is what they say. It's a minimalistic web application framework. Okay. They also say it lacks most of the features of a regular framework, of a full stack framework. It's actually quite depressing definition, right? It doesn't have any authentication, doesn't have any database abstraction, or it doesn't have any validation or templating engine. Actually, why use it if it doesn't offer anything? I continued. I asked Silex, and that's how Silex defines a micro framework. It's a simple, single app. It allows you to create simple single app, single file apps. Right, so everything is defined in a single file, and it's simple. Still didn't satisfy me. I looked further. When Symfony announced the Symfony microkernel trait, there was a blog post Javier wrote, and he tried to define the micro framework in that blog post as well. So first thing he says, it's a minimalistic web application framework. So that's probably taken from Wikipedia. But he also says that something that's nowhere written, no micro framework claims that it's a fast and small framework. And is it? Is it really, a micro framework, is it really fast and small? That's what we try to answer today as well. This is not written in any definitions, but kind of most of us expect it to be like that, right? To be fast and small. But I think most important thing is that it's not only simple, but not opinionated framework. What this means is that it doesn't force any decisions on you. It lets you to make those decisions. So it's a nice thing, being in control. So it's nice that they allow you to make those decisions, but it's also bad because they allow you to make those decisions in the same time. Because you need to make them. There's some effort needed. And I also looked at some other technologies like the Flask from Python. And I really like the definition. They say it's not about having a single file application at all. Although it is possible. Okay, so it's optional. It also doesn't mean it lacks functionality. What it means, it's simple but extensible. Okay, so core is very simple, easy to understand, but it's so powerful that you can add features to it by adding extensions. So basically pick and choose what you want to use. What kind of a database abstraction, what kind of a templating system, everything is optional. So it's simple but extensible. It's also not opinionated. Second time we see this in the definition. I also found this on the Programmer Stack Exchange. So the guy basically says the micro framework is a shorthand for framework written by someone annoyed by established frameworks, perceived complexity, and that micro framework is going to gradually accumulate a similar amount of complexity. Basically, it will eventually become those frameworks that the guy initially was annoyed with. But back to the serious things. This is a definition I'll use for this talk. Okay? Microframework is simple but extensible. It is not opinionated, so you're in the control, you choose how to do things. And it might be placed in a single file, but it doesn't have to. All right? So let's have a look at the documentation example of how Symfony can work as a microframework with the microkernel trait. This is a live coding demo. I'm using my famous skill of typing with my mind. So we'll just create a new, fresh directory and install Symfony. So it's not a full stack Symfony standard edition, but there's actually quite a lot of packages in there. We only include the Symfony core framework. So all the core components, all the core bundles, and bridges. Okay. Everything was loaded from the cache, so I didn't really use the Wi-Fi here. So let's start. What we have here is the standard composer project with vendors, composer JSON, composer log. And we'll create a web directory where we put the front controller index.php. Okay, front controller is something that all of your requests are going through. In there, we'll initialize the autoloader to have all the classes available. And we'll create a class upkernel. That's similar to what you have in the Symfony Standard Edition. We'll also extend the kernel. Right, so this class is usually found in your application. We're just writing it from scratch instead of using the provided Standard Edition template. But there's one difference. What we'll do is we'll include the microkernel trait, which will slightly change the behavior of this kernel. We'll add the missing methods that abstract classes or traits force us to define. Register bundles is a method known from Standard Edition. It's just a list of bundles you want to use. But configure roots and configure container are a bit different. They're not available in Standard Edition. These are forced by the microkernel trait. Let me explain this a little bit. So Standard Edition has this method down there, register container configuration, which basically loads the configuration file for the container and bootstraps it. You might not notice that because that's generated for you. Usually, if you never look at the upkernel, you never see that, but that's there for you, and you can change. For example, if you don't like YMLs, you could change it to XMLs by changing this loaded file here. What happens in the microkernel trait is that that method is overwritten, and it actually uses a closure to load container configuration. And instead of from a file, it expects a method load roots. The kernel dot is a kernel colon is a special notation meaning reference the current kernel. Right? So it will look for load roots in the correct kernel. It will also configure the container, so that's another method here. And load roots actually initialize the root collection and calls the configure roots. That's the method we need to implement. So both of these are provided by the trait. And that's it. There's no magic. It just changes the way container configuration is loaded. So let's give it a go. We won't use any, well, we actually need to use one bundle. We need to use the framework bundle. Because if you notice one of the previous methods I've shown you, it actually initialized routing service on the framework bundle. So at least we need to this single bundle to be initialized. And to configure, we actually need to provide the secret because that's the only parameter that's required to be configured by the framework bundle. If you use Standard Edition, these things are usually configured for you in your configuration files. This is the minimum amount of configuration we need to do. And we can start defining our roots. Just in line in the kernel. We again use the special notation for the kernel, reference the current class, and say, whenever you hit the main page, call this homepage action, which can again be inlined in here. Container is supposed to get the request or return the response, so that's what we're going to do. Just hello world. Maybe let's take something from the request to make it more interesting, and provide a default value there. Okay, we're almost done. Notice so far we've been editing this single file only. So that's a whole Symfony application in a single file. We need to initialize it. So similar to the standard edition, in what you find in the front controller, we initialize the kernel with proper options, def environment, debugging enabled. We create the request from globals and pass that request to the kernel to handle, and it's supposed to return the response, which you can in turn return back to the client. And then if you use that, we can also terminate so that does some additional processing after the response was returned to the client. So let's give it a go. Let's start a simple web server. And basically, our application is ready. Let's try with an argument. Yep. So that's your Symfony application in a single file. Okay. So it's simple but extensible. I think we all agree it's very simple. It's extensible because you can basically install any bundle Symfony provides. And that's probably the biggest repository of extensions, is the Symfony Framework One's bundles. It's not opinionated. You can change the things work. Okay, we defined our controller in the kernel, but you can easily extract it to a class, just like you have in the standard edition, move it there. You can register your container configuration whenever you want, wherever you want. So it's up to you. It's in a single file, but it doesn't have to. We could easily extract it to a separate file class and use it like that. This is what we've done. There's a bit over 200,000 lines of vendor code, so still a lot in vendors that we actually don't use because we included the whole Symfony core. There's 46 lines of our code that we actually have written. And those times, this is a result of profiling I've done in my secret data center in Eastern Germany. No, but really, that's just on my laptop, so it's no way, that's just that day that these were the results. I just want you to see the comparison more or less. But, a few milliseconds this way or that way, that just doesn't matter that much. For now, it doesn't tell you much, but we'll see it in comparison with other setups later. So this would be the end of my talk if I was only talking about the microkernel trait, because there's really not much about it. It's just a trait that changes behavior of your kernel slightly if you really want to use Symfony as a micro framework. It's also easy to roll back to the standard edition by just removing the trait and setting up configuration files, so it's pretty flexible. But I want to go a step further and see if we can simplify that even more. So one of the main components Symfony offers is the HTTP foundation and the HTTP kernel. HTTP kernel relies on the HTTP foundation. What HTTP kernel defines, the most important interface, is this one, HTTP kernel interface. It basically describes how HTTP works. It gets the request. The first argument is important for our talk only. It gets the request and it returns the response. Right? And in the component, we have several kernels actually defined. One is the kernel. That's the one you usually extend. And that's the one that Symfony Standard Edition extends. But there's also HTTP kernel, which also implements the HTTP kernel interface, but it's used by the kernel. What kernel does is it bootstraps the container configuration and looks for a service called HTTP kernel, and will call it to handle requests. And then HTTP kernel, in turn, will use the event dispatcher to fire events and call it the controller. So it's very simple, really. We'll look into the HTTP kernel now, right? So what we were implementing before was the kernel. We'll look into the HTTP kernel. So let's just remove what we've done so far, create a new directory. And this time, we only initialize a single component. We only require a single component, which is the HTTP kernel. It brings some dependencies, but there's much less dependencies than in the previous example. Again, we have a similar directory structure, compose.json vendor. What we do now, create the front controller again, but this time we'll create a slightly different kernel. Because this time we'll extend the HTTP kernel, which is a bit different animal. And you can see that by looking at how it's actually initialized. So, and looking at its dependencies. So it heavily uses the event dispatcher. So that's the first requirement. It also needs so-called controller resolver, which knows how to find the controller and call it. The rest is similar. That's still HTTP kernel interface. So we create the request from globals, pass the request to the kernel, and then render the response. Okay? And the terminate at the end. And this is actually a working application. It throws an exception. We get a 500 error because we didn't tell Symfony how to handle that request. What you see there is the not found HTTP exception. So it actually throws a nice exception. Okay, it didn't know what to do with this request because there's no routing in place. Let's fix it. What we'll do is we'll listen to events. So the HTTP kernel heavily uses the event dispatcher, as I mentioned earlier. And we'll listen to the kernel.exception. Okay? Because resource not found exception, it's something we can handle. It should be a 500 error. That's not a server error. It's just a 404. So we say whenever kernel.exception happens, if that exception is not found HTTP exception, let's just return the response with a status code 404 not found. Right? Other cases will be still let through, so we'll get to 500. You can also nicely see how Symfony leverages HTTP. It takes care of returning proper response code for you. Right, so let's try it. Now it's 404 not found. Okay, so let's have a look at how we could actually handle a request here. Let's move it first to the kernel so that we don't have too much code outside. So we'll just override the handle method and add a new one to boot the kernel before the request is handled. And there we have access to the dispatcher we have passed into the constructor, so we can just add the lister. That's it. That works as exactly the same as before. Let's listen to another event, which is kernel.request. That's the first event that Symfony throws when the request comes in. Okay, it doesn't try to handle controllers, handle routing, anything. It just fires an event. And actually, that's most of it is just firing events, what the kernel does. And here we'll implement a simple routing. Okay, if that's the home page, we know that that should be handled by homepage actions, so we'll set a special attribute. So request attributes is something that is meant to be set during the request. That's the only parameter back on the request that actually is meant to be modified. And what Symfony will look for is the _controller attribute. If it doesn't find it, it throws that resource not found exception. That's why we had that error initially. But if it's found, that is going to be your controller. So we can say, just handle it with this homepage action. All other paths, all other resources will be ignored. All right, so we just need to create it. That's boring. We just get the request and then return the response. I'll just move fast forward. That works. Okay, just with the HTTP kernel. And then 404 works as well. So, oh, that's really not real. So here's the request that comes in. We get to the response. And the first thing Symfony does is, okay, I've got the request, I'll notify others about it. And it fires the kernel.request event. And it just tells the dispatcher, here's the event, do something about it. And the event dispatcher knows there are other guys that are interested in it. So in a standard edition, you have like 5 default listeners already registered for you. You can add additional ones. The idea is, it's kind of another way of achieving dependency inversion. Because the kernel doesn't know anything about those guys at the top. It just tells the event dispatcher, if anyone is interested, let them know. And the event dispatcher knows those guys and will just let them know about this event. So when we want to add another one, we just tell the dispatcher that there's another guy interested in this event, and nothing in the kernel changes. Okay? So it's very extensible. And one thing that happens in the standard edition here is router listener kicks in that implements all the routing stuff and sets it back on the request so that Symfony knows what to call. And that's kind of an event we listen to implement our simple routing as well. Interesting thing is that one of these listeners could actually set a response on the event, in which case Symfony will return it back to the client without calling any controllers or any other processing. It will just return it. Well, it will actually fire other events, but then eventually it will be returned without calling the controller. So we can interrupt the processing quite early during the request. But if it returns the request, Symfony will not call the controller yet. Sorry, if it will set the controller on the request, it will not call it yet. It will just fire kernel.controller event. So we still have some possibilities here to change that, to change the controller, to alter it. There's several default event listeners that implement some things like param converter. If you use param converter to inject objects into your controller, that's where it happens. There's another one, controller arguments, which was recently introduced, which is not used for anything yet. But it will be soon. Then the controller is called. It returns the response. Symfony doesn't return it yet, but it throws kernel.response. Okay, I've got a response. Maybe someone still wants to do something about it. There's few, in standard edition, there's few listeners that implement things like, if you ever wondered how it happens that debug toolbar is injected into your page, this is where it happens. So there's an event list web debug toolbar listener that looks at the response. Okay, this is an HTML response. It has an ending body tag. I'll just inject it before the ending body tag. Otherwise, it doesn't do anything. Finish request with some additional processing again. And kernel view, which is called when you return something that's not a response from a controller. So if you ever use the template annotation to return an array from a controller, this is where it's handled. Okay, yeah, Symfony looks, in this listener, it looks into the template annotation. Okay, I need to render a template, passes the array into the template and returns the response. So you can recover from not returning a response from your controllers. So you could potentially return objects and automatically serialize them with this event. One use case. And finally, kernel terminate. That's triggered by that kernel terminate function call after the response was returned to the client. So you can still do some things like right after the page was rendered. So this is where emails are sent, and actually some web servers can detach from that request, and like Nginx can actually close the connection and still do some processing. Shouldn't be abused, but it's possible. Right, so what we've done here with the event listener, it's still simple but extensible. You can still add easily new event listeners. And it doesn't have to be in this class. You can organize things the way you want. You can implement listeners separate classes, organize the directory structure the way you want. So it's still not opinionated. And it's like my poor benchmark says, it's a bit more performant. But notice that it doesn't offer you much. You can't use bundles in this case because you don't have the kernel, right? So you should answer yourself a question, is it worth it? Our routing is very limited. If you start adding more routes and try matching the paths with regular expressions to handle parameters and stuff, that's going to be a job we quickly hate. So let's just include the routing component and let it handle the boring part. More coding. And we won't need the previous code, and we'll just register a new listener on kernel request on the current kernel. And it will actually initialize the routing and handle it. Right, so first thing we need to do is to create the URL matcher that well, we might get the request from the event, obviously, and then initialize the URL matcher. That has a few dependencies. One is the root collection, so a collection of roots that you have in your application, and then the request context, which is at the moment not important. Right, so we need those roots defined. Let's just delegate this to another function. Method, and that should create a root collection. That's all routing component classes. And we'll only define one single root for the home page. All right? And routing is decoupled from other Symfony components. So what we do here is we just define, OK, whenever slash is hit, the main page is hit, just return these parameters, attributes. They can be whatever. And by convention, we use it, for example, for the controller part. Right, so what's left to do is to actually handle the routing. So match the request. And it should find the root and return us the parameters that was as a result of matching. If there's no root found, it will throw an exception, which we'll already handle, resource not found HTTP exception. And then we set the result on the attributes. Right, it actually throws another exception, and we need to convert it to resource not found. Yeah, but that's just a tiny thing. Let's just see how this works. Works like before. Okay, just now we don't have to implement the routing. And there's actually, this work we've done here is actually not needed. Oops, sorry, too far. Because there's a router listener that actually does this work for us. So instead of registering a custom, doing it manually, we can just use the built-in one that will do exactly the same. Pass the matcher and the request context. Sorry, I'm typing so slow today. Request stack, yeah. So this is how it compares. A bit more files, not that much, 38,000. These two cases we just used with a custom router and with the built-in router listener. Still quite performant. And notice memory usage is a bit lower compared with the kernel trait. So after a while, it might start to be a bit tedious and boring to do everything manually. So let's get back to the idea of the kernel. This actually shows how nicely Symfony components are decoupled from each other. We installed HTTP kernel, and none of the dependency injection or config components or YAML were not automatically brought in, because there are optional dependencies to the HTTP kernel component. So we need to manually register them if we need to use the certain features like the kernel. Otherwise, they're not needed. So let's refactor this a bit. Our app kernel is not going to be an app kernel anymore. That's HTTP kernel. So I'm going to rename it and actually extract it to a separate class. Okay, it starts to be too much in that single file. Let's just move it out. I'll create a source directory, which I already added to the composer.json. So the classes will be auto-loaded. Move it there. Okay. Next, I will also create the app kernel that will extend kernel. Okay, remember, we have two kernels. The outer one, which is the application kernel that bootstraps the whole dependency injection thing, and then it calls one of the services, which is HTTP kernel, that's supposed to handle the request. We won't use any bundles for now, and just load the container configuration from an external YML file. Somewhere in the config directory, config YML. Yep, we need to create it. It's not there yet. Am I with time? Okay. So just create a config file. And here, instead of initializing the HTTP kernel, we initialize the application kernel. So the app kernel will look for HTTP kernel service. We need to register it. It would be normally registered by the framework bundle. Okay, framework bundle is like a main framework stuff initialized there for you. Since we didn't use it, we need to do it manually. And our kernel relies on the event dispatcher and the controller resolver, which will in turn will register it as services. Event dispatcher and the controller resolver. Simple definitions. Cool. That should work. Yeah. All the controllers work, and the not found listener works as well. Okay, it starts to be a bit more code, more dependencies. We almost doubled them in terms of lines of code. A bit slower, but still that's nothing, right? Compared to what you would have to do manually to handle all of these things, I think it's worth it. So let's have a look at how we could actually remove more code and introduce new features. Let's initialize the framework bundle, include the framework bundle as well. So we'll register it. Cool. And this will make that these services are actually registered in the framework bundle. So let's get rid of them. We don't need them. We'll just configure the framework extension and the secrets. That's all we have to do. And we don't need my HTTP kernel because we can use the default built-in one. It does exactly the same. And for now, we'll get back to the idea of the microkernel trait, right? Which, if you remember, already defines register container configuration. So we'll move that container definitions from there to the configure container method. Very quickly, that's not needed. Cool. And we need the routing, so let's define it. For now, it's going to be in the same kernel to show the flexibility. Similar method we used before. Yeah, works like before. And this is a comparison. Even more code, we doubled again vendor libraries. Framework bundle brought lots of stuff. But there's less code we needed to write. And it's still comparable to the first kernel we wrote in terms of the whole execution time. What we're building is really not opinionated. We can change things whatever we like. So we don't like having controllers inside of a kernel anymore, or there's too many of them. We can always extract them, refactor, move that to separate classes. And it's going to just work as it used to work before. Right? Just don't forget to include the import statements. Right. We only need to change the definition of the routing. So instead of kernel, that's going to be our controller class now. Notice we're not initializing it here. We'll let Symfony to do it. We just say, this is the class with this method. Still works, surprisingly. I'm really not making mistakes today. OK. And the power of this is that we can still extend it. So you need Twig, just install the Twig bundle. OK, bundles are basically things that extend your framework with third-party libraries. So Twig is something not really Symfony related. You can use it in any PHP project. But we have a bundle for it that integrates that library inside of the framework. And And since there's so many of those bundles, Symfony is one of the most extensible frameworks in PHP. So after including it in Composer, we need to just initialize it and also configure it in the container. So we just enable the container configurations. One thing we'll do here is just to define paths to the templates. Instead of using hard-coded, full paths to the templates, we'll just define a namespace. So we say this directory at the top level of our project will be mapped to up. So we can reference it with a shortcut, with an alias, instead of giving it a full path. Right. I'll extend the base controller just for convenience, because it offers me access to the container and handy shortcuts, like this render that calls the tweak service. And we'll use the alias we just defined to render the template. Pass some arguments, options to the template. Right, so final thing, we need the template. We'll just render some simple HTML to show that it's actually HTML rendered. So just bold the name. OK, we request it now, and now it's rendered with the tweak service instead of just returning response. We brought even more dependencies. It's even slower, but still fast. That's just my laptop, so on a proper server, it will be a lot quicker. And we can still move things around. Microkernel trait is not really something micro, as we discussed with Kieran earlier today. It's just a sexy name, I guess. You don't like it anymore. The nice thing, even if you start with the Symfony project from start, or include it later on, you can always roll back to full stack standard edition, or just the regular config files. You just remove the trait, and include container configuration in there, right? And start defining your stuff in there. Since we removed the trait, we removed the routing definitions, we need to, oops, sorry. Let me repeat that. We need to add a routing file, but nothing happens magically here. We need to tell Symfony where to find the routing definitions. So, well, first let's define it, the roots. So we just have a single homepage one. That maps to the home controller hello action, homepage action. Yep. Symfony won't load it until we tell it. So framework bundle, we configure the router to look at that config file. That's what you see in the standard edition as well. That's exactly the same. Right? And this actually works. So we migrated from the microkernel trait back to the normal one, let's say. It's a bit, no, that's negligible, but it was just my laptop test. So it's exactly the same as with the trait, I would say. So we can include anything that notice that we didn't start with the Symfony standard edition. But still, any bundle that works with standard edition works with this. So you want to serialize stuff, just include GMS serializer, enable the bundle. Right, that will register it in our app. And you're ready to go. Let's say this action should return JSON whenever someone requests it. So let's just add a condition. Very naive content negotiation. If client requested application JSON, let's just serialize some stuff. Okay, if it's in accept header, let's use the GMS serializer service to serialize an array. Which is a bit stupid in this case because we're just serializing an array, but you can imagine this could be an object. It would make more sense. Right, our name serialized, and then we just need to wrap it into the response. And pass the content, 200, maybe some headers. That's JSON after all. Right. So this works like before, but now if we send the accept header, we get JSON back. Okay? Took us seconds to extend it. This is what we came up with. directory structure that's quite different from the standard edition. Notice there's no bundles. Do you need a bundle in your project? Okay. I think bundles are good for extensions if you have something, or if you offer something that can be used in other projects, if that's reusable. In your project, maybe that's not needed. Maybe you can have bundleless apps, right? And we have a simple structure config, source for our code, templates, so designers are not lost looking for templates somewhere in app resources, views, whatever. Single front controller. And this can be organized the way you like it. It's all up to you. Symfony doesn't get into your way. And the final comparison. These are still small numbers. I think the amount of things you get is much more important from like raw performance like this. Nice thing about it is that you could actually, in the whole microservice era, you can actually have multiple applications, each using slightly different kernel, optimized for what they want to do. So you could have standard edition for most of your projects that are not, for example, not performance sensitive. And then that small bit that's very performance sensitive, just do it simplest way possible without all the overhead of the default bundles that the standard edition comes with. Don't quote these numbers, and this is really not a scientific way of doing benchmarks. I did it like in half an hour before the talk, so. So, some takeouts. I think people go with micro frameworks because they think they're fast and small, even though they don't really promise that. But they might be fast and slow, fast and small. I really need a fast and small. How much time? I'm just wrapping up. Okay. And that's not really true. They might be fast and small in a Hello World application, but then you start adding stuff, and you're actually reinventing Symfony. I heard so many stories, people starting with Silex, and they were introducing concepts they knew from Symfony. They were basically copying it. And they did it in a less performant way than that's actually built with Symfony. So micro framework as it is, it doesn't offer you too many features, so it actually, you'll need to provide those features yourself. And you'll replicate what you know from other frameworks, so you'll actually end up building Symfony. And I think you're not in a business of writing frameworks, unless you are, then go ahead. But most of the time, we are here to solve business problems. And we shouldn't be taking care of requests, responses. We should just use them. I would go that far, that should be part of the language even. But if you really insist on using micro frameworks, make sure that you choose one that's very simple and extensible. And it offers you a good community with good amount of extensions, quality extensions. In this case, I think Symfony is one of your best choices. Silex, it doesn't have such a big community as Symfony. And it doesn't have that big amount of extensions as Symfony has. So I think it's a good learning exercise. So it's good to do that exercise, build your own stuff from components to learn how Symfony works. And it might be a good consideration for microservices, okay, where you can build each service a slightly different way just to optimize it for the job it's supposed to be doing. And I want you to remember, by this talk I wanted to show you how simple Symfony is. Okay, usually starting with Symfony Standard Edition, which seems quite big and bloated, but it just installs lots of stuff. And you can disable those things. The same way we went through from simple components to a more complex setup, you can go back. You can install Standard Edition and disable stuff. Remove doctrine, remove security, and simplify it. Thank you. And please rate my talk on joined in. I think I don't have time for questions. But ask me questions afterwards. And sorry for such a long talk. And thank you.